Hello, this is Nitin Dahad with the Times. I'm talking now to Ben White, who's the founder and CEO of a company called Phlux Technology in the UK. Ben, hello.
Hey Nitin, how you doing? It's great to meet you.
Good. Good to meet you too. So you just announced a fundraising of £9 million, which is probably about 12, $13 million, and total funding so far of about $18 million. So tell us a little bit about what you do, so that we can understand a little bit more about the company and the context.
Okay, yeah, thanks very much. So we at Flex make infrared sensor chips, so compound
Mm,
semiconductor chips for the next generation of communication and vision systems. And so really just to put it into context is that we see the world around us using visible light, but there's another world out there that we can't see in the infrared. And infrared spectrum is really, really important. It's because it's how data is sent all around the world over optical fibers. And it's how machines and robots see the world around them in 3D using just a really high precision version of radar, but using light instead of radio waves called LiDAR. And really at Flux, what we're doing is developing the next generation of chips that will support both of those systems. Within infrared sensors, unfortunately, silicon is a wonderful material, but one of the things it can't do is absorb light in the shortwave infrared. It's just the fundamentally can't do that. And so people use different materials, and most commonly compound semiconductors and a material called InGaAs, which has been used, really invented like in the 70s. It became very, very popular and wiped out the thing that came before it called germanium. But since then, that's really run out of steam in these applications. And by run out of steam, I mean that it's got really to the limit of speed and how much data you can use to transmit using these detectors in com systems, and also sensitivity. So in vision systems, the sensitivity is really key for producing really crystal clear images around you. And that's a material parameter that just it fundamentally can't squeeze any more out of it. So at Flux, we've developed this new material system. It's a bit of a mouthful called AlGas-B, and we've called it noiseless InGaAs that uses antimony. And that overcomes like a fundamental limit because it has a much higher like gain bandwidth product, it's called. So it's much faster and much more sensitive than anything else. So that enables you to transfer more data or detect like lower signals or lower amounts of light using this technology.
And is this part of the work? Is this a research that you did and you spun out of the University of Sheffield, or so is this the basis of the company?
Yeah, so this is the fruit of about 10 years of research actually at the University of Sheffield. And my
Mm,
co-founders, who are both professors, actually came up with this idea. So Chi Hing Tan and Zhou Shen Eng have been researching antimonides at Sheffield for a long time. And the
mm,
reason for that is that Sheffield is home to one of the national centres for 3.5 compound semiconductor research. So they have
mm.
a load of really high value machines and growth equipment at the university that we can use to make strange, weird, and wonderful compound semiconductor materials. And so about yeah, in 2020 or 2019, we had this breakthrough and showed that this material system that we've developed had some really, really unique electronic properties. And through that, that was through that the research group at the time, which some of the work I was part of. And then in 2020, we created Flux to commercialize that as a vehicle to commercialize it, and have done two funding rounds since.
And I think you've had some success because got manufactured chips. You've got some early, I guess, proof of concept customers who are, generating revenue. Just tell us a little bit about that journey.
Yeah, we've done a lot in 5 years and it's absolutely flown by. But so since spinning out, yeah, absolutely. I think the first couple of years were really building our like MVP, so the minimum viable product, and just making something that works. So our core expertise is the material, and there's quite a lot of work that you need to turn a material into a chip that actually does something for someone. So the first 2 years were that. Then we closed our £4 million seed round, which was led by Octopus Ventures here in the UK, and that was used to really start scaling. So we invested in a new facility. We put a big supply chain together, and we've grown from about 5 to 20 people today. And so, really going into production and having a supply chain set up that goes into Taiwan, so we can start manufacturing in high volume.
And you're manufacturing chips.
No, as unpopular it is that we actually make a product, a semiconductor
Okay.
chip that we ship to our customers.
And and your early customers, all of them in North America at the moment. Just tell us sort of the range of applications.
Yeah, so where we've started out is that we have started out with a strategy of serving beachhead market, so high value, low volume customers and applications initially. That's because we're supply limited. And so most of our customers are based in North America at the moment, but we are seeing traction globally in Europe and Asia too. We've got a huge amount of leads across the whole world now.
And I think those applications, things like sensing and low volume applications, like in construction, LiDAR, and I guess you said optical test equipment, and also a couple of automotive. Just tell us, if you can, a little bit about those.
Yeah, so infrared detectors go into a wide number of applications, but where we're seeing traction at the moment is in optical fiber test equipment. So this is using detectors to monitor the health of optical fiber networks all around the world. It's used in like really high value mapping and surveying equipment that's used for monitoring how vertical a skyscraper is or coastal erosion, deforestation. And finally, in defense and security equipment. And so monitoring the distance to objects in front of you using lasers and detectors. And so that's what we call our beachhead markets, where we've got initial traction. And we're using that as our initial like customer base to learn from and improve these products. And then it goes into a much broader range of applications after that. So you mentioned automotive. So for the next generation of like car safety features, which is generally called ADAS, like emergency pedestrian braking, a lot of the best performing systems are powered by infrared light. And so we're seeing huge traction there too. Gas sensing is another good example of that. You can see carbon dioxide and methane in
Mm,
the infrared. And so you can
mm.
track and monitor emissions from oil and gas refineries or in farms or slurry pits and things like that. So to really start monitoring carbon footprints. And then beyond there, the huge application for this is in communication systems. And so beachhead market would be free space optical comms, which we're seeing a huge amount of activity all around the
Okay,
world at the moment. We provide the chip that turns the infrared lights back into an electrical signal, but at very high speed. And that's
okay,
often coupled with a transimpedance amplifier or an amplifier afterwards.
okay.
And so that's our next generation of product line. At the moment, we have detector chips, but also full receiver or systems too, including the APD and all the amplification circuit behind it.
So, what kind of impact you're going to be at OFC this week? What kind of impact do you think you're going to make at OFC? Do you think people will be interested?
So really, the core problem that we're trying to solve is that people all around the world find ways to use more data, and getting that data to people's homes is a real problem. Like the optical fiber that's used to carry this data is already in the ground, and so we've got to find a way to increase the bandwidth of these systems while like not having massive infrastructure projects to dig up the fiber and lay new stuff. So the only way you can do that is by improving the chips that power these communication systems. And that's what we do at Phlux, is that we've got the next generation of communication chip that's going to power the next people getting more and more data around the world. So where we come in really is that getting data from data centers to people's homes, that our chipset, we want it to become the dominant technology used in that application space. And that's really our objective for Phlux of the next few years.
And I guess so. What you're for the with the money, you're going to be sort of expanding your offices and network and setting up in North America.
Yeah, so at the moment we're completely based in the UK, only UK based employees. But for us, one of the big objectives for our Series A round as well is to put a sales and distribution network around the world so we can reach customers everywhere and build relationships with customers in the US and in Asia too. So sales and distribution office most likely in the US and somewhere in East Asia, but TBD.
All right. Well, Ben, good luck. Thank you very much.
Thank you very much, Nitin. It's been a pleasure.